Hello everyone, my name is Ram Iyer. I'm here to give you an introduction about my team's project this semester, AI Playtesting. We are all students at Carnegie Mellon University's Entertainment Technology Center, and this has been the project for our current semester. Here's my extremely talented team. Danny, Sichi, and me have been programmers for this project, and Zahang has been a game designer. The basic idea behind this project is to develop a reinforcement learning agent to playtest a turn based combat card game that can then help us with balancing the game. Now, although we do use a specific game called Slay the Spire, which is a combat card game, what we are trying to do is come up with something that is general and can be extended to other similar types of games and potentially could also be extended to other strategy games in general. Before we go any further, I want to talk a little bit about the current challenges with human playtesting and especially how this applies in the context of game balance. The first problem is that playtesting can be very expensive. Not only is it expensive in terms of the monetary investment required to get people to play your game, there's also a time investment required by the game creators to support the playtesting process. The next problem is that a lot of strategy games have a skill curve where people may not be able to identify the dominant strategies to win the game when they are playtesting. The third problem is that some of the data that is collected during playtesting can be very messy. And when I say messy, what I really mean is that it will be unstructured in some ways. For example, if you want, for the purpose of game balance, if you want to ask how difficult is a particular part of the game, just asking a question like that may get you a variety of responses that may not be something that you are looking for. You can also have a scale where somebody ranks the difficulty from 1 to 5, but different people may interpret the scale in different ways. Taking the skill curve into consideration, some playtesters might already be experienced and some may not, and this can also affect the way that they rate how difficult the game was. And this can result in some sort of variability that is undesirable. Now, this being said, there is a place for human playtesting because at the end of the day, the game is going to be played by actual humans. However, what we are looking to do is substitute some part of the human playtesting process with AI playtesting so that the design iteration that goes in creating the game might be faster. So the next question is, why are we using reinforcement learning as opposed to another traditional supervised learning approach? Well, the first thing is that we do not have access to an existing data set that a supervised machine learning approach requires. And this means that for us, reinforcement learning makes a lot of sense because it can generate samples and learn from scratch. The second thing is that reinforcement learning is independent of the game rules, and as a result of that, it is generalizable. Even if we had access to a precompiled data set, every time the game goes through an update where some of the rules change, even if the deck that is used to play the game changes, we would need a whole new data set to train a supervised machine learning agent. However, with reinforcement learning, the agent can just generate samples and learn from scratch. Lastly, performance can exceed expectations if the reinforcement learning agent is trained well. And it is possible that the reinforcement learning agent may sometimes perform better than a human. It can identify strategies that possibly a human could not have identified in a precompiled data set if that was available. The game that we have chosen for this project is called Slay the Spire. It has been developed by a studio called Megacrit. A lot of us in the team definitely like this game a lot. We have played many hours of this game, and we think that there is a deep strategy to it, which makes it a good candidate for reinforcement learning. If you have never played this game before, I would definitely recommend that you go check it out. I'm going to give a link to the Steam page in the description of this video. All right, so now we come to the reinforcement learning problem formulation. And what I'm going to do here is try to explain how the reinforcement learning agent is going to perceive the game and how it works behind the scenes. At this point, I'm going to assume that you have a little bit of knowledge about how combat card games work in general. So let's say that we have the reinforcement learning agent at hand. What goes in as input is the observation of the current state of the game. Let's call this the game state. And this is comprised of all the different quantities that you would see on the screen if you were playing the game. Now, what comes out of the RL agent is some sort of meaningful information that can help decide which card to play in the current game state. So, if you want to dive deeper into this, here's the game state, which can be thought of as a composition of the following values: the player health, the player energy, boss health, boss energy, player buffs, and boss intent. All of these values together can construe what the current game state is. We have a neural network, which can be thought of as being the brain of the reinforcement learning agent. And what we get as output is the reward from playing all of these different cards in your hand. Let's say that card 2 gave you the maximum reward, you would play that card. And this is how the reinforcement learning agent is going to play the game. That's all I have for now. Thank you very much for watching till the end. I'm also including a link in the description below to a demo video of our application. In that video, you'll be able to see how we have achieved some of the things that I've talked about in this video. I've also included a link to our project website in the description. On our project website, you'll find a development log that gives you a detailed description of all of the things that we have built over the last 13 weeks. Please do check that out as well. Thank you once again and have a good day.